All right, so now we're going to go over how to read radioactivity in a graph, though. So just like what we were doing in a chart, now it's just looking more visual through a graph here. So anytime you get a graph of radioactivity, I would suggest the first thing you do, just to analyze it here. First thing, look at your x-axis and see what it's reading. What is it telling you? So here, the x-axis is telling us the number of days. So I know this is kind of hard to see, but this one's 8, 16, 24, 32, and 40. So we're looking at these number of half-life, or how many days that we're looking at, how long it takes. Then on your y-axis over here, we see that it is the percent of iodine remaining. So we're not actually, it's not an actual gram, it's an actual percent. Okay. So what we're going to do is we're going to look at part A here. What percent of the isotope remains after 32 days? And we've got to be exact. So I think what a lot of you are going to want to do is you're going to want to go to 32 days on the graph and go read directly here. And you're going to probably guess about 5%, which yes, if you're estimating, it's about 5%. But here we can actually be exact. So again, if we remember, what half-life is how long it takes for half of the sample to decay. So in this case, I'm going to change colors here. This case, we are starting with 100% of the sample. Oh, probably new color, not that one. 100% of the sample here. And we've got to look to see when does half of that. So half of 100, we take 100 divided by 2, and that's when we're going to get 50. So right about this point here. This is when half of the sample has decayed. So again, that's very, very, very important that you remember we are trying to figure out when half of this sample has decayed. And that's going to tell us what one half-life is. So in this case, one half-life is 8 days. So at this point, we know we have 50% left. And 50% left, okay? Now what we do is we figure out, okay, now take half of this. So we take half of this and put it in your calculator, 50 divided by 2, that's going to be 25%. So that's at this point here, 25, excuse my writing here, percent, okay? Over here, remember, we're trying to get to 32 days, so we got to get to this point. So we've got to divide 25 by 2. That's going to be 12.5. Oh my goodness, I got it right here. Ah, nope, erase that. 12.5 is just for 24 days. Then at 32 days, we take 12.5, divide that by 2, and we're going to be left with 6.25. Ah, oh my goodness. Oh gosh. 6 point. Oh no, oh no. Oh no. Can come out of that. All right, 6.25. That is how long it takes, or what percent remains after 32 days? Only 6.25%. So that would be your answer here, 6.25. All right. So part B, what is the half-life of iodine 131? So again, the half-life, remember, let's use that terminology. Think of this. How much does it take? How long does it take for half of the sample to decay? So how long does it take for it to get to 50%? It takes 8 days. So we would go find 50% on the graph. We see how long that took. It takes 8 days. 8 days to do that. Okay, so now what I want you to do, I want you to go try to answer this question now. So just like what you were doing on the previous worksheet, I want you to set up the chart here. Patients administered 20 milligrams of iodine 131. So this is your starting amount, 20 milligrams. How many milligrams of this radioactive isotope will remain in the body after 24 days? So you've got to go figure out how much is left. If we're starting with 20 milligrams, how long or how much is left after 24 days? Let me know if you have any questions. Good luck.